Hi, question number 4. A uniform beam has length 2.4 meters and weight 68 newtons. The beam is hinged at a fixed point of a vertical wall and held in a horizontal position by a light rod of 2.5 meters. One end of the rod is attached to the beam at a point 0.7 meters from the wall, and the other end of the rod is attached to the wall at a point vertically below the hinge. The beam carries a load of 750 newtons at its end. Find the force in the rod. The components of the force exerted by the hinge on the beam are X Newton horizontally towards the wall and Y Newtons vertically downwards. Find the values of X and Y. Now for this question, they want us to find the force in the rod here. First of all, there's a force acting downward, which is in a clockwise direction as negative. And then there's the beam itself, has a mass of 68 newtons. And this would be then 1.2, because that's where the center of mass is here. And this is 1.2. So I'm going to take moment about H, the hinge, that's where all the force is going to be acting, is equal to 0. So I'm going to say then, this one also is acting downward, so it's a negative force, alright, because it tends to go in clockwise direction. So I got minus 68 times the distance away from the hinge is 1.2, then minus 750, and the distance away from the hinge is 2.4, okay, and there's a force, this one here is acting upwards, alright, it's trying to support the beam. So if this force is acting upward, so this tends to go in a anti-clockwise direction, which is then positive. So I'm going to then add the force times the sine of theta times its distance away from it, which is then 0.7, distance away from the hinge, 0.7, and all of that should be then equal to 0. Basically, what we're saying is that minus 68 times 1.2 is this much, then minus 750 times 2.4, we're getting that much. So therefore, I've got minus 1881.6. Here I've got plus rather, F times the sine of theta. Sine is opposite of a hypotenuse. If you want to find the opposite, you can use Pythagoras theorem. So h squared is going to be equal to 2.5 square minus 0.7 square. So h is going to be equal to the square root of 5.76, which then turns out to be 2.4. So this is 2.4. Now, the sine is opposite of the hypotenuse, so 2.4 over 2.5 times the distance, of course, 0.7. So what we're saying is that the force is equal to 1881.6, and all of that here, 2.4 over 2.5, then times 0.7, which is then 0.672. So 0.672, and so F is going to equal to all of that divided by 0.672, so 1881.6 divided by, the result is 2,800 newtons. So that's the force in the rod. The second part of the question is asking us to find the X and Y components of this force if it's acting in the horizontal direction. So we got then the force here is 2,800, so the X horizontal component of X is going to be then, this is theta, so I'm going to say then 2,800, which is the X horizontal component, X component of the force, times the cos of theta. That means 2,800 times cos is adjacent of the hypotenuse, and let's see what we get. I divide all of that by 2.5, 784 newtons. Nothing difficult. And the Y components of the force, of course, the force acting now vertically. Okay, so the y component is going to be equal to 2800 times the sine of theta. And remember, there's two other forces. This one is going up, okay, so it's a positive, minus the two going down, 68 and 750. And so that's going to give us the y component, so which is then, sorry about that, so there we go. So 2800 times the sine of that, the sine is 2.4 over 2.5, this much, and then take away 750, take away 68, and we get 1870. So the y component turns out to be 1870 newtons. Here we are for this question. Take care. Well done.